And the way that you represent variation, and there's two different types of variation that you need to be aware of. The first is direct variation. The second is inverse variation or indirect variation. If you're dealing with direct variation, what that's identifying is you have this relationship. Right? It's a power function, okay, where n is some power, whereas and k is called your constant of variation. Okay, so k is the constant of variation. In order to solve for k, what you're going to do to solve and work through these all the variation problems is you're going to choose the correct relationship. Okay, so in this particular case, you're using y equals kx to some power, whatever it happens to be, and you'll see it as we go through some of the questions. Okay. And then after you choose the correct relation, you're going to plug in the given values. And you're going to solve for k. Okay, you want to find what your constant of variation is. So when we look at a problem like this, it will specifically tell you which relation you're looking at. So here, y varies directly with x. The way that you're going to interpret that is you will write it y varies directly, you're going to set equal, and then because it's a direct variation, you're going to use k times x. Okay, and then you're going to plug in the values that you're given. So I'm going to plug in a 48 for y. I'm going to plug in a -6 for x, and I'm going to solve this for k. So if I divide both sides by -6, I get k is equal to, here, 6 goes in, or 48 divided by 6 gives me -6, gives me -8. And so there's my k value. Once you find your k value, you're going to rewrite equation. By plugging in the k value from step 2. Okay, so what you do is you now take this equation right here, and you're going to write it as y equals whatever your k value is times x. Okay, so that's going to be the equation that models that situation. And then the final thing that you're going to do is you're going to evaluate a new set of terms. And so when they ask you to evaluate y when x is -3, you're basically just going to take y of -3, evaluate what you get, in this case 24, and that would be your solution. And now, as far as the types of problems that you're going to see here, is the variation could be direct or inverse, and then it might be directly with x squared, with x cubed. Right, I'm going to do this top problem, give you a few more minutes to work on the other ones, but I just want to make sure that you can follow the process. All right, so the first thing is to identify what type of variation you have. So direct variation begins with the form y equals kx. Now, this one, it just says with x. So it's y equals k times x to the first. Plug in my numbers. -60 over 7 is equal to k times my -6. I'm going to solve for k. So solving for k, I multiply by 1 over -6. Again, that's equivalent to dividing by -6. But the reason I use the multiply by the reciprocal is that it just makes it easier here in this case to cancel. So I get my k value to be 10 over 7, and I can write that equation. So my first answer is y equals 10 over 7 x. The second part to this equation is to evaluate when x is 6. And so when I substitute that in, I get y equals 10 over 7 times 6. Nothing cancels. And so my answer is 60 over 7. And so those would be my two solutions. I'm going to go ahead and do the green one too because this one relates a power other than 1. So you have direct variation, and it says y varies directly, so that means equals k times. Again, anytime you see varies, you're just basically saying equals k times whatever comes next. Direct means I'm going to multiply by what I see, the square of x. So I get y equals k times x squared. Plug in my values. 10 over 7 is equal to k times 3 squared. To solve for k, I'm going to multiply by the reciprocal 1 over 9. 1 over 9, that cancels 3 squared and 9, leaving me my k value to be nothing cancels here, so I get 10 over 63. So my equation is going to be y equals my k value, 10 over 63 x squared. Make sure you complete the exact equation. And then when I evaluate it, I plug in the -2. So I get y equals 10 over 63 times -2 squared. When I simplify what I have, I get -2 squared is 4 times 10 is 40 over 63. Nothing cancels from that, and so that would be my solution. Okay, so if I'm looking at this final problem here, y varies, so that tells me I'm looking at y equals k times something. It's direct variation, so the next thing is going to be multiplied in the numerator here, cube of x, so x cubed. Okay, read carefully. There are students who misread things. Or if it says square of x, they might write square root, or the cube of x, they might write cube root. Make sure you read it carefully. Okay, I'm then going to substitute in my numbers, so -1296 equals k times 12 cubed. And so what I'm going to do here is use a calculator. And so when I solve for this, I'm going to use the solve feature. -1296 equals, I'm going to go ahead and say k, although I could replace it. Instead of k with a parentheses, I need to explicitly multiply. So 12 cubed, and I'm solving for k. Close that off. And I get my answer -3/4. Okay, so there's my k value. I can write my equation, y equals -3/4 x cubed. Again, all I did is I replaced k with the value that I tested for. And then the last thing here is to basically evaluate y of -8 in this case. Because I have my calculator, I'm going to go ahead and just write this equation here. -3/4 times the quantity -8 cubed. Notice this time I put the entire base factor -8 in parentheses to make sure that the negative signs are applied correctly. I get 384 for my solution.